I'm going to talk to you today about a presentation I've called Return of the Hypercube, or how I learned to stop worrying and love the OBT. Now, the way I do presentations, I come up with a title first and I figure out the content later. So I really like this one. So I hope the presentation follows through. So a little bit about me. This is my first time at a Boston DBT meetup. I've been a user of DBT for a while, but I'm based in the UK. We do have offices in Boston and analytics engineers based there. I'm head of customer analytics. I'm primarily focused on marketing and operations, trying to make data valuable in the point of the customer journey. So being predictive and active. Part of my role does look after BI, traditional business intelligence concerns with dashboards. So a little bit about me. Apart from being head of customer analytics, I used to run a dance music party in London. Data is my first love, but it used to be trance music. If anybody knows, that's a subgenre of a subgenre. I started running during the pandemic, maybe like many of you guys. Love the Garmin, so it's got lots of data. It's got a data lovers watch on there, so it's great. Get one. And interesting fact, I'm a co-founder of a whiskey bar in Scotland. As opposed to Drizzly, I'm trying to encourage people to get out and drink. And if you're ever in Scotland, go to Inverness and have some whiskey. Good. So a little bit about the UK's #1 SME insurance broker. So we service small businesses, and we've been successful because we've tech and data into kind of one of the traditional or second oldest professions. And we're expanding both in the UK and US. We've seen continued growth despite those enormous challenges of the pandemic. In the UK, we're behind all the major UK financial price comparison sites. I think the US is still a way away from having these kind of consolidated giants where you can really compare financial products, but it's been quite established in the UK, and for SME insurance, we're behind basically all of them. So that's good. And much like everybody, probably we're hiring for DBT, get in touch. Agendas, I've got to go, why are we here? What's this all about? WTF is a Hypercube. It's a good name. Is there anything else? Using DBT to build the blocks of the Hypercube, and how where DBT fits in the architecture, and what this did for us, and then hopefully a little bit of time for Q&A. So a very existential question: why are we here for this particular DBT meeting? It's about this. Our analytics architecture changed. So I'm a little bit old school, probably older than a lot of people on the call. I came from a more traditional BI background. We had a stack that was pretty old in the tooth now. I think probably not that many people will still be on this sort of stack, but we were on SQL Server and using SQL Server integration services as our data ETL tool integration platform. Our end users were using Excel, and they used something called SQL Service Analysis Service on the back of that. Now, SSAS is basically an OLAP cube technology. So this is something that would take information, data, and aggregate it up and make interactive queries lightning fast for our users. So if we look at our current architecture, obviously SQL Server has been replaced by Snowflake, SSIS is replaced by DBT, Excel has been, probably like many of you guys, will have been replaced by Looker. And then SSAS, what's been replaced by? It's been replaced kind of by Snowflake. There's no kind of parallel. I think the thought is that Looker runs natively on these columnar, massively parallel cloud databases. So why do we need OLAP cube? Because everything is blindingly fast anyway. So why? Let's have a look at a typical data set. This is something I got on the internet, data model for e-commerce by Barry Williams. So I'll give him his full credit, nothing to do with me. What we can see is that it's really highly normalized. There's lots of relationships, everything's got a third normal form, no redundancy, lots of joins everywhere, and lots of one-to-many joins. And many of these might have, outer join requirements. You can see some little circles around those little crow's feet everywhere. So that's nasty, because writing aggregate queries that span these tables is absolutely non-trivial. Just trying to get any kind of measure out of that, as soon as you're combining information from some tables, you've got to really think hard about. And what's more, running aggregate queries against those is slow. Even if you've got some massively fast parallel cloud database, it's still all this indexing. It's going to take time, and probably it's going to be expensive as well, because we're paying for that querying. Now, we've used Looker, and some of you might also do, if you're using Looker against anything that looks like that. Now, they solved a problem, which is the first one, which is writing aggregate queries that span tables is non-trivial. Look at how they solved the problem. Has anybody ever taken the time to understand that? I never have, but they solved the problem. Great. But what's the problem? Has anybody seen this screen before? Okay, so this is basically the loading data screen. It's awful. And this is a curious cat. Now, I think analysts, they need to be curious, right? So this is how we will need to go to the bottom of what's happening. Now, if every time we want to ask a question, we have this enormous surging query that goes out onto the ether and gathers up that data and costs money, then you're going to kill the curiosity inherent in the cat. So not good. And at the same time, somebody's making a lot of money out of that. And obviously we're paying for some very lavish lifestyles out there as analysts. So good, we don't like that. We want to live in a more equal world, don't we? What is a hypercube? What can it do for us? Interactivity, maybe a pop quiz. What is a hypercube? Is it a way to make interrogating data faster? B, a multidimensional array of data? Or C, a name that makes data sound cooler than it actually is? Any thoughts? You can unmute if you've got it. Whoever gets that wins a prize. I'm not sure what it is yet. Okay.
Not them.
Yes, good. Good. It was a trick. Well done. Good. Danny's been through this before, so I do know Danny. Good. So yes, it's all of them. Good. But if we go to a standard definition, so a cube is just a shorthand for a multi-dimensional data set. And given data can have an arbitrary number of dimensions, it doesn't have to be 3 like a cube. And when you've got more than 3, you just call it hypercube. And then you sound like data's all sexy and cool and people are interested in what you're talking about. Cube data, to get cube data, you frequently prepare them using a star schema. Now, many analysts nowadays, they don't know what about star schemas because they're off in their own kind of normalized world. This star schema is a traditional business intelligence structure. If you haven't come across it, you can read up about them, but it's fundamentally about way of preparing data. And you basically split your data into measures and dimensions. And once you've done that, then you can get the data and you can load it into a cube. So many people will already know that. So just to recap, we have facts, which is just anything that's quantitative that you can measure, a piece of information like a sale or download. Then you have your conformed dimensions. Conformed dimension is basically just the set of data attributes that are referenced in multiple database tables and are consistently addressed. So they're always talking about the same domain entity in the same domain way. And that's an important part of this, making sure that a person is a person or an order is an order. It has to be consistent across the different data sets. And finally, just the star schema, which is basically just where you have the facts just stored in a fact table and only the facts with basically surrogate keys to those dimensions. And it looks like a star. This is probably very much old hat to a lot of people I grew up with. But then, even if you get this done, you still get lots of joins. And in Looker, there's no way to do fact-to-fact joins. So you always choose a root, which would be your fact table or a dimension table, but then you always need to go to dimensions. So it's just not a multi-fact data structure isn't suitable for a relational tool like Looker. And it doesn't really get us away from all these joins. So we need something else, going back to the cube analogy. What's the replacement for our OLAP cube? So building blocks. What do we need to build? We need to build this cube. We need to first design the cube, right? So this is what we do. We choose events as the universal grain. So because what we're talking about is multidimensional cubes, multi-facts. We say something that happened is universal. You can always talk about something that happened. You can have a transaction was made, a policy was purchased, a person visited a store. And what we need to do is you just design the facts and your conformed dimensions. You build those dimensions, and once you have those dimensions, you use those dimensions to build denormalized fact tables. So this is you start with a traditional approach of your fact table. And then you add all the dimensions onto the fact row and you denormalize it. So you squash it, you flatten it. You've got a very long fact table. We use DBT to encode all business logic onto that fact table. So therefore, you don't need any inherent knowledge between the relationships between the facts and any of its parent dimensions, and you don't need to apply any kind of calculation for anything that's not an aggregate query, obviously, because you can't encode those on a row level. And then finally, you bring all of those multiple fact tables into one big table. So you have multiple fact tables effectively all together, Now, because they share all the dimension table, they may share most of them. They don't have to be perfectly conformed in terms of all fact tables have to have all the dimensions, but you just bring them all into your one big table. And finally, you create aggregations on top of that. So that's what we do SB for a subset of our data sets. In that model, every dimension is a reusable analytical asset. Once you've created your dimension, you treat that like gold dust, right? And you can use that across any fact process. And also every fact row is golden because no business logic is needed to derive its context. As an analyst, you don't even have to know how to use a joint. You just need to know how to use the sums or max or whatever aggregate function you want to apply. You don't have to worry about the relationship of a measure to anything else in the business. So just to walk through that in step-by-step, here's a relational model that we actually had at Simply Business. Very simplified. This is our contact center. In the contact center, you can imagine that we make calls, we have contact requests coming in from customers saying, call me. We have consultants that make calls. We have a consultant that is part of an organization chart. They'll be in a team, which is itself a part of a hierarchy. We might need to know more about their metadata. And then you might have sales off the back of that. So that's a relational model. And actually, we used to have that in Looker. We have these full outer one-to-end joins, and we get that lovely symmetric aggregate queries that we had beforehand. And concurrent querying speed was just atrocious. So step one in that is just model the first star. In this case, it's just, you can see we have a contact requests. So contact requests become a fact contact request. And in fact, we talked about fact contact request events, things that can happen on the contact request. The contact request will go through various stages. It might be insected, it might be passed to the dialer, might be killed. They're all in the domain space of the contact requests and things that are happening on the contact requests. So that's the fact contact request events. And we have all of the conformed dimensions into the dimension tables, and we split those out. I've put dim date there because dim date is a universal thing that when something happens is all for an event is universal. I've put, it may be implied because Looker, you don't actually ever need to build a date dimension, but in some tools you might have to construct your own date hierarchies. Any numeric elements in dimensions are not facts. They are merely attributes and should never be used in aggregate querying. So that's just to make that point. And that makes that clarity between what is a dimension and what is a fact really clear. In the previous model, you have dimensions and measures all mixed together in the same model. Little kind of point of housekeeping is that every attribute in a dimension will have that dimension's prefix. If something like name or, I don't know, telephone number or something generic like location could be shared across different dimensions, always prefix every single attribute with the dimension name before the attribute. This will help ensure column names are unique later when we squash it all down. And then we want to denormalize the star. So we've created the star. Now we're going to denormalize it. How do we do that? We can just simply do a lovely dim star. Now, I'm sure some people are horrified by looking at the stars, but what we've said is that we've constructed these very carefully. We're curating the attributes up front. Now we use the dim star just because now we can conform it. We make sure that everything that we build in the dimension is always available across any of the normalized fact rows. So that's why we use dim star. And effectively there, if you, for a very particular purpose, if you need to control the dimensions in a fact row, just put a view on top of it that's specific for that fact row, and then restrict the dimensional columns if needed for a specific cube. Then we model the next star. So remember we had this one, we talked about contact requests. So now we want to talk about, say, call events, right? So now we've got dim call measures and the other dimensions that were on the first normalized fact row. But now we've got more dimensions because it's further down in the process, we've got more dimensions involved. And then you just keep denormalizing each star. So just keep on going and on. There we go. So you just repeat lots of times. Now we want to union them all and this little function is just, I call it stardust or gold dust. I love this. It's such a simple thing, but it just means that every column is always joined, unioned in the appropriate location. If anybody's ever had to manage union relationships and the fact that everything has to be aligned, you don't have to do that anymore. DBT has this wonderful piece of code. Love it. And that's what this looks like for this cube, where we've got all of the different fact tables that are denormalized. And then we just use that lovely union relations. And what we have is really one very large table. I've put 3.5 kilometers long. It's just that big. Probably is it H8 in the scale that we were talking about beforehand. And you can see it's got every single attribute from every single dimension measure and all the measures all there. Lovely. You can then get pre-filtered versions of the master OBT. So this is the master OBT. OBT is just one big table. So you could then just filter that by saying, well, actually, this master OBT, we just want to get like a territory view, or we want to get a state view, a country, however we want to filter it in ways that make sense to the business, because it's just like, here's your subset of your data. There you go. You're only ever going to be querying that side of things. Maybe it's a product line, and you can really use, again, DBT to make those super simply. So you can just go through all of your territories and then off you go. It's a very simple query now. And maybe some people are talking about, well, isn't this horrifically redundant? It absolutely is. This is horrible. In the old days of SSIS, and sorry, I won't go all the way back, but in the old days of SSIS and SQL services, this would be anathema. But we have Snowflake now, and storage is just like water, and redundancy on the data storage is absolutely fine. And when we have redundancy on the data storage, we can get away from the intense compute costs. So this is great. Finally, you just define your pre-computed aggregations on the key dimensions to metrics to mirror that OLAP cube functionality. Now, different tool sets might have different ways of doing this. Now, we use Looker facilitates this greatly because it's already got aggregate awareness, as they call it, so you can create these very easily. I have seen in DBT there's an outstanding request for DBT materialized views, which would be aggregates. I don't know how that's standing. Different architectures might have different ways of creating it, but once we've got that flattened OBT, aggregations are so much faster to compute. So that's the thing. You're not having to join. You just literally go down, and your aggregation queries forward. So you can create bunches of aggregations at very little time and cost. And if you're querying dimensions and measures in the aggregation, performance will be even faster than the raw OBT. But remember, performance in the raw OBT is blazingly fast because it's literally a scan down a single table. So here we can go from massively aggregated to the absolute in-depth detail of absolutely each event that's ever happening. Even if we're in the detail of the event, it's still fast. And that's something we can never really do on OLAP cubes, because you're always having to get to a certain level of aggregation. Otherwise, the memory requirements would be enormous. So that's it. Just a couple of pointers: slowly changing dimensions. Type 1, slowly change dimensions, i.e. one thing that changes in a dimension, in a single dimension, the attribute changes. If that happens, watch out, because you've now got to replace that everywhere. So think about the strategy you're going to use. We have a strategy that works very well for us, and obviously on this type of model, type 2s, where after a certain time, so you have an attribute, and after a certain time it goes to another attribute. Inherently on this model work perfectly, and there's not a lot of there's zero SCG type 2 management. It's great. So what did this do for us as a big business? It reduced query time massively. If we look at the previous model, if you think of that relation one to many, one outer joins, we had full outer joins in some cases. It's dropped query times from minutes to seconds, and sometimes less. And we have these reusable data assets from both dimensions and fact rows that can then be used in other processes and other queues, and really simplifies the querying by analysts. Anybody can just go in there. Okay, I understand everything about the context of what's happening, and data application. So we've now hooked these data tables up to close to real-time consultant dashboards that they don't have to know any of the business logic. They just take that data as a flat file. And for me, it really continues that kind of encoding of best practice and data modeling for our new starters, because obviously not everybody's comfortable or knows about facts and dimensions, and it guides us towards best practice. There we go. So that's the end of my presentation. I hope you found it useful.
Thank you so much, Alex. That was incredible. Okay, so we've got some questions. Ashley, I'm going to call you out. I know you didn't have a question, but Ashley dropped in a comment. And I know Ashley, I worked with her at HubSpot, and I know she understands the Looker side of things like very deeply. So Ashley, do you want to just speak to your comment about why multi-factors and why that resonated so well with you?
Yeah, absolutely. I really appreciated that succinct way of putting it. How I had been trying to describe it to people is I had a classic situation where my subject matter expertise is in one of our core like business dimensions. It's partner accounts that we have at HubSpot. And then of course, the events that everybody cares about the most are all of our revenue changes. So I have an Explorer that's built around the partner as a dimension that joins in just about anything you could ever want to join in for a partner, so that we have that for like agile analytics. And then separately, we have explorers that are about the revenue events that go on those. So I've been trying to articulate this to people of, okay, use the one that's about partners for anything that's about partners, unless money is involved. And as soon as money is involved, go use the money explorer that has the same dimensions, because we have that kind of partner account dimension modeled well, but doesn't have all of the extra stuff, because we get very detailed on one end or the other, everything about revenue or everything about the accounts. So that's a really helpful way to put it. Of, for me, trying to put two facts together would be trying to put all of this information about what's happening to partner accounts next to all of this information that's happening about our revenue. And there was just enough of a gut instinct with how I was setting things up in Looker that I was like, this is where we draw the line. But I really appreciate having some words to put to that.
I've seen business users, obviously, what they try to do is use Looker merge queries, which is, again, at the end of the world, isn't it? Yeah.
I actually use merged queries pretty heavily, but you have to have an intention and kind of know why you're doing it, and you can get a lot done with them. But certainly if you can solve that problem with better data modeling upstream, that is the way to solve it.
So I really found that DBT was essential in that process.
Yeah, that makes a ton of sense.
Awesome, thanks. Okay, D. Rubin, you had a question. Are you able to come off mute? There we go.
Yeah,
Dan.
I was just wondering, how big are your OBTs? And then follow up, are they clustered and how?
So they're 3.5 kilometers. So truly, like, we have millions and millions and millions of fact rows, and I've never actually stopped to count the number of columns, but we're in the realms of hundreds. And regard to clustering, we haven't gone out of our way to performance tune at the moment. The scale that we're dealing with, the performance is absolutely fine. I wouldn't say that we're in the realms of big data. We haven't done modeling of page views, for example, or going through the site, which would lead us to probably think about maybe some form of aggregation up front. But when we're dealing with things like calls in a contact center, so it's quite manageable.
Yeah, I was wondering, because we're struggling with some of our web analytics stuff, which is approaching the scale of hundreds of millions of records a day.
No, sure. Yeah, we're far away from that. But I think the principle can hold firm. I suppose it's what level do you need to drill down at what point, and what you could, I would work through, can we deal with some certain form of aggregation, and then apply the same principles.
Thank you.
Great. Anna, did you want to come off mute and ask your question?
I was very curious how operationally you manage when some of this changes. Do you drop your entire OBT and recreate it?
Yes, we do. Yes. So we actually have a process that will drop it actually even weekly. So this is the way that we actually manage our SCD type ones, is that we do incremental builds that take the previous 7 days worth of data, and then we do full batch recreations every 7 days on a downtime window on a Sunday. So that, because we have that luxury that it's not 24/7 access, that's the way we've done it. But you can imagine doing things in parallel that would get you to the same result. And just to drive home a point, these things are every half an hour for our contact center. So this is massive wide tables. Each run is not a significant overhead on Snowflake. But it's like we're doing the kind of the complexity of the queries to build the model is a kind of complexity of an end user trying to get more than some basic analysis out of the front end. So the difference is that we just do that once, and then it's available for everybody.
Makes sense. Thank you.
Awesome. Okay, Alex, I've got one. It sounds like the way you're describing it, this is an evolution in terms of how you were previously building and designing things. So I'm curious how you've had to change and adapt your development workflow to support designing towards this architecture. It's like, what part of your organization owns this work? What roles or teams? What types of challenges there are in that?
Okay, so yeah, so we got onto the Looker bus quite early on, and we were building PDTs, I think probably like any early Looker user was, and it really led us down to jettisoning best practice data modeling principles. And I think the introduction of DBT, that's what precipitated, or not immediately, because I think what initially happened was that the models just got taken wholesale from PDTs to DBT, and the modeling principles weren't there. So the challenges are, are we going to invest our engineers' time in recreating these things? Now, for me, the difference was that our operational analytics are really complicated. They drive half of our business, and we've got something like 100 people running dashboards frequently throughout the day. So at that point, you just think something's got to give. We've got escalating Snowflake costs. We're contributing to those luxury yachts, and we've lost that curiosity. We've got those offline analysts that they're scared to look into the data. They'll do something, they'll leave it running, and that's what I really wanted to change. Luckily, in my team, we've got people who are obviously skilled at SQL. They upskilled in DBT quickly, and then we just thought about how we would structure this. So the journey's not complete. So I keep on saying about these sort of golden dimensional fact row data sets. Now we've got them, but they're not used everywhere because we still have plenty of legacy. And I guess my challenge is process by process is to introduce them. So we started off in a very specific, I guess you would call it a data mart, but the key thing is that those dimensions are conformed to the business domain. So they can be then rolled out to new business areas.
Have you had any challenges with adoption of the Hypercube, or teams don't want to make the cut over and want to continue it?
No, as soon as people start using it, it's because it's day and night. So yeah, it sells itself.
That's awesome. Okay, let me just check if any. I think I got all the questions. Oh, we just had another one come in. Neil, if you want to come off mute.
Sure. Thank you so much for this talk. It was really interesting, and I know this has been focused on the engineering side of it, on the technical side of it, but I was curious about the impact on the business side. What I said was often we as analysts or analytics engineers build tables and then metrics on top of those tables, or maybe Looker explorers for one particular team. There's metrics for product team, for a marketing team. In your experience, or maybe do you think there's a way in which having all of the relevant information in one larger table can help break down the silos, not so much in data, but just in like operations, because a product team is only concerned about what it's measuring.
So the thing is, because each part of the cube is componentized itself. If you're talking about calls, for example, if you need to join that to another part of the process, obviously this domain space was around operation, like contact center operations. But you may want to know, like a product manager might want to know, what's the flow between my customer through from online to offline. Now, what you're interested in more would be about the calls that customer is making. You can reuse these fact rows because you've conformed the dimension. You can say, I've got a conformed customer dimension, I've got a conformed date dimension. I now have the way of joining that process. So you can just join them in that way. Does that make sense? So once you have the one fact, because the Hypercube OBT is just an aggregation of a unioning of lots of minor OBTs. Each flattened fact row. So each flattened fact table can be used independently, because without any knowledge of how it fits together, because the dimensions conform it all.
That makes sense. So it seems like if you want to explore outside of your domain, then the data that you would need is in some ways already present.
Exactly, through the conformed dimension.
Okay, thank you.